The story is that the rock are as massive as 10 tons and can land quite a distance from the volcano. The volcano throws a rock from 50 meters height at an angle of 60 degrees and the rock lands 800 meters away. What must be the initial velocity of the rock to reach that distance? First thing you want to do is draw a diagram because it makes it easier to see. We'll be using this formula. All you have to do is plug in what we already know, the gravity and the distance. What we don't know is time, so we have to use another formula to find time over here. So we'll be using this formula to find time, and you won't get an exact number, but you'll get a type of formula like this. So then you would plug this in for every t you see, and when you do that, you can cross out some things and you'll be left with one initial velocity left, and you want to have the initial velocity on one side and all the numbers on the other side like this, and in the end you'll get 93.48 meters over second. For part B, it's asking how high will the rock go up in the air. For this one, we'll be using this formula. Again, you plug in for what we already know, like gravity. For Vy squared, we already know that's 0. For Voy squared, it's the component. So we have to put we have to use the initial velocity for what we calculated earlier, 93.48 sine 60, because now this is the y component. And you want to move the distance from one side and all the numbers on the other side, so you get 334.38. But the tricky part is that you cannot forget to add 50 meters because it's already 50 meters up in the air, because what we calculated here, it's only at the top for when the rock was thrown. For part C, it's asking with what velocity would the rock hit the ground. For this one, we'll be using this equation. Now for t, we already have the equation for t from part A, where t is equal to 1600 over an initial velocity, but we already found out what initial velocity is, so you go ahead and plug in initial velocity and get 1702 seconds. So, and for Voy, that's V sine, so the same thing, 93.48 sine 60 degrees minus the gravity and minus time that we already found. So to find the overall velocity, we'll be using this formula. Now we found it's negative 88.12 meters for the y component, so we plug that in. We haven't found for the x component yet, which is fine. We did it over here. Vx equals 93.48 cosine 60 degrees, which is 46.74. You plug it in, and then at the end you get 100.14 meters over second.